In this sixth topic, we're going to discuss the idea of negative angles and angles that are greater than 360 degrees, one complete revolution. I've drawn here an angle of 30 degrees. Okay, 30 degrees would mean I'm measuring from 0 on the positive side of the x-axis up to that point over there. However, what I could also do is I could start at 0 degrees over here and I could measure around in the opposite direction. Okay, so that red angle, I'm going to write it down here, would be 30 degrees minus 360, which would be minus 330 degrees. Okay, now these angles are important because they finish in exactly the same place. And because they finish in the same place, their x, y, and r values are going to be identical, in which case their trig ratios are going to be identical. So for example, sine of 30 degrees and sine of minus 330 degrees, if you type it into your calculator, are both going to be a half. We can also get an angle that is much bigger. So for example, I could take an angle from 0 degrees and I could go around 360 and a bit more. That black angle would be 30 degrees plus 360 degrees, which is 390. And if you were to work out sine of 390 degrees, you would also get a half. Okay, again, because the angles finish in the same place, that is what is important, because they finish in the same place, their x, y's and r's are the same. I could take an angle that goes around twice and finishes up over there. So now that angle would be 30 degrees plus 2 times 360 degrees. Okay, so our 720 plus our 30 degrees is going to give us an angle of 750 degrees. If you type sine of 750 degrees, you're also going to find that your answer is a half. Okay, let's do one more example in a negative direction. Okay, I could take this angle here. I could go around once and all the way around to that point over there. The size of that angle would be 30 degrees minus 2 times 360. Okay, 30 degrees minus 720 is going to give me minus 690 degrees. If you take your calculator and you work out sine of that, you're going to land up with an answer of a half. And it's really important that you understand here that because all those angles finish in the same place, sine is going to be the same, cos is going to be the same, tan is going to be the same. Now, there are an infinite number of angles that are going to finish up there, because clearly we can add or subtract any multiple of 360 degrees. And so the way we are going to write this down is we're going to say, well, all those angles that finish in that place over there satisfy that they are 30 degrees plus some multiple of 360, and k has to be an element of the set of integers. It can be either positive, okay, or negative. In this example over there, okay, if I talk about just my 30 degrees, I would really be adding 0 times 360. Okay, if k is minus 1, 30 minus 360. If k is 1, 30 plus 360. If k is 2, 30 plus 720. If k is minus 2, 30 minus 720. And all the angles that finish in that place over there can be written as 30 plus an integer multiple of 360 degrees. Now, this is really very useful in two sections. Obviously, it helps us tidy up some more expressions, either just using our special angles or using our reduction formula. Okay, and it also is incredibly important when we get to solving trig equations later on. Okay, so let's have a look at the examples on the right hand side over there. Okay, now we're going to use our reduction formula as opposed to just using our calculators to get these answers. So if I take minus 120 degrees, the easiest way to tackle that is to say that it is sine of minus 120. You can just add 360 degrees. So that is simply going to become sine of 240. We can use our reduction formula. What quadrant third, what sine negative, what axis x, what ratio, it stays the same, and minus sine 60 is going to be minus root 3 over 2. When you have an angle that is bigger than 480 degrees, that is bigger than 360, 480 degrees, I'm simply going to take my 480 and I'm minusing the 360. In other words, this tan of 480 is exactly the same as tan of 120. What quadrant? Second. What sine negative? What axis x? What ratio? Well, it's going to be tan of 60, and tan of 60 is my y value over my x value. X is 1, so I can just leave my answer as minus root 3. If I take minus 1020, okay, a negative angle. Okay, I'm going to add 360. Not good enough. I'm going to add 360 again. Still not good enough. I need to add 360 again. I'm essentially just adding multiples of 360 degrees until I land up with a positive angle. And cos of 60 is a half. All right, now in these examples over here, theta minus 90. I don't know about theta minus 90. I know about 90 minus theta, or 90 plus theta, or 270 plus or minus theta. So the trick here is always to add 360 degrees. So cos of theta minus 90 is exactly the same as cos of 270 plus theta. All I've done is use the same concept that by adding a complete revolution, I've finished in the same place. My ratio must be the same. All right, so 270 plus theta, what quadrant? Fourth. What sine? Positive. What axis? Y. In other words, cos is going to change to its co-function sine. Over here, theta minus 180. Again, it's a negative angle. How do I cope with a negative angle? I'm just going to add 360 degrees. So this becomes tan 360 minus 180. What quadrant? Third. What sine? Positive. What axis? X. What ratio? It stays the same. Here again, it's negative. How am I going to cope with it? I'm just going to add 360 degrees, and that becomes sine of 90 plus theta. What quadrant? Second. What sine? Positive. What axis? Y. What ratio? I take the co-function, and my answer is cos. Okay, now in a test, you're more likely to get a couple of these things put together in one sum. So the first thing I'm going to do is look at this angle over here. it's negative. Okay, it's clearly a negative angle. How do I cope with the negative angle? I keep adding 360 until I'm comfortable. So I'm going to add 360. It's still negative. I'm going to add 2 complete revolutions. And so if I take minus 450 plus 720, okay, I'm going to land up with sine of 270 plus theta. This angle is clearly much too big. So if the angle's too big, we're going to subtract multiples of 360 until we're comfortable. So if I take that 540 and I minus 360 degrees, I'm going to land up with cos of 180 degrees plus theta. My denominator, cos of 180 minus theta, that one's already fine. I don't have to add or subtract a complete revolution. I know how to handle that. Now I put this in here for a very specific reason. That cos is squared. Please remember that that square means that we're going to work out cos of 180 minus theta all squared. Okay, that's what it actually means. Now I'm going to use my reduction formula. What quadrant fourth, what sign negative, what axis y, what ratio it changes to its co-function. What quadrant third, what sign negative, what axis x, what ratio it stays the same. Here, what quadrant second, what sign negative. But that negative is going to be squared. Okay? So minus times a minus actually gives me a plus. The moment you are working with a reduction formula and a ratio squared, it doesn't really matter whether it's positive or negative. Squaring it, it's always going to be positive. What axis x, what ratio, it stays the same. So my denominator just becomes cos squared theta. Okay, tidying that up, my answer becomes cos squared theta over cos squared theta, which is 1.